Okay, class. Look at the screen. Let's start with an easy question again. What's the answer for this? 3? Or how do you get 3? Okay, then which law do we use now? So 3 log base 10 with a 10, right? So this gives us 3 times 1, which is 3. Okay, good. Then typically we don't even write this, right? We just write LG. Okay, because it is understood that this is actually log base 10. Okay? What about log base 16? What does this give us?
4.
Log base 2 to the power 4, which gives us 4 times 1, right? Okay, so I skip one step over here, which you are able to do so also, because it's just bring the power down over there. Okay, last one, log base 424. How about this? Because we cannot rewrite 24 as 4 to the power of something, we now need to do something different. Remember, when I see a question like this, what goes through my mind is, what is the power of 4 that results in a value of 24? So 4 to the power of something equals to 24. What is that something over there? Okay, something in between 2 and 3. Are you alright? Something between 2 and 3. So exactly how are we going to find out? So that is today's lesson. I will now let this be equal to x for now. I let it be equal to x. Of course, eventually I want to find x, right? If I change this to our exponential form, what do we have? What is the base? 4 power x equals to 24. Okay. Then the next thing that I need to do is something that I've been repeating. Here I have an equation. Something equals to something. If I do something on one side, I must do the same thing on the other side for them to be equal, right? Whether it is multiplied by 2, multiplied by 2, divided by 3, divided by 3, square root, whatever it is, for them to remain equal, I must do the same for both sides. Make sense? Now, next thing. Our calculator is unable to do log base 4. But what is it that our calculator can do? Log base 10 or log base E. Okay, which one would you like to use? Log base 10 because it is common lah, okay? I'll just call it this way. It is common to use log base 10. So that is why it's called the common log. Now, I want to put log base 10 on both sides. How do I introduce the log base 10 to both sides? Simply, it's not multiplied. I am not multiplying by log. There is no such thing as multiplying by log. Rather, listen carefully to what I'm saying. I take logarithms on both sides. Okay, this is how we say it. We take logarithms on both sides. So it becomes log 4 to the power x equals to log 24. Okay, now, right hand side. Can your calculator do this? Yes, right? What about the other side? Cannot because it's the power x, right? But what can we do? Yeah, every time I see a log, don't care the base, don't care this one. As long as I see a power, I will bring it down. Okay, so that's what we do. I'm gonna do x log 4 equals to log 24. Now what this means is that it is literally x times log 4. It is literally over there on the board y times log ax. Okay, it's just multiplication. And what was it that we want to find out initially? X. How do I make x the subject?
Divide by log 4.
I divide by log 4 on both sides. Like I said, this is literally x multiplied by a number. This is just a number which your calculator can give you. Don't be afraid of the letters LG. Okay, when it is log base 10, 4, simply it's a number. Your calculator will do it for you, no problem. So, we want to find the value of x. we get x equals to log 24 over log 4. Now use your calculator to find out what that value is. Okay, you get 2.29, some more? 5, I want 5 SF. 2, 5. Okay, this is 5 SF. Then you round it off to 3 SF, 2.29, 3 SF. Okay, now to convince yourself, I want you to put in this value into this part. 4 to the power of this value. Do you get 24? Do you get exactly 24? That's because you use 5 SF, right? Yeah, I want you to use the exact one. Use the button A and S, answer. So 4 to the power of answer. Do you get exactly 24? You should. Yes? Yes, you can do it with ln as well. Instead of taking log, why not try using ln? Now, your turn to try. Ln 24 divided by ln 4. Do you get the same answer?
Yes.
Have you tried it? Try it. Convince yourself. Instead of using log base 10, try ln. Your calculator also has ln, ln. You convince yourself? Same value, right? Okay, then what is the summary over here? This is our key step. Instead of using log base 10, log base e, I could have chosen log base c, for example. Then 4 to the power of x equals to log base c, 24, right? I could have done that. Any base I like. So then I continue, I get x log base c 4 equals to log base c 24, x equals to log base c 24 over log base c 4. Okay, this is a more general form in blue color. Instead of restricting ourselves to base 10, base e, I can let it be log base c, isn't it? Anything you like, 5, 10, 15, whatever. Now, instead of these numbers, 24 and 4, could they also be anything?
X and Y.
Let's generalize them. Okay, so then we have the next law, log base a b. If I want to change the base, for example, to log base c, watch carefully. I'm going to use colors, okay? So this is A and I've got B. Base A with B. I want to change it to log base C. That will be divided by log base C. Let me put this in black. Okay. You will result in a fraction. I've already changed the base, as you can see. From red, it became red color A, became green color C. Now in the numerator, I follow this one over here, B. Then in the denominator, whatever is at the bottom, I put it over here. This is the general form. It's going to look like this. Okay, you can refer back to your previous example that I went through. It is also in our textbook. We had log 24 divided by log 4. So how I remember is, changing the base, don't need to remember one, because that's the whole purpose of changing the base. The number at the bottom goes below. The number that is not at the bottom, which is kind of at the top, goes to the top. That's how I remember it. Okay? Any questions? Let's practice, okay? With work example 20. Log base 5, 0.8. Can your calculator do log base 5?
No.
Okay, then we need to change base. What do you want to change it to?
10.
You can choose base 10 or base E. Normally we choose base 10. So this gives us log divided by log. Okay, what goes at the top, what goes to the bottom?
0.8 and 5.
0.8 at the top and 5 at the bottom. Use your calculator, evaluate. Okay, so 3SF negative 0.139, right?
Yes.
What does this mean to you?
The
Log-
power is negative.
Log base 5, 0.8, you get a negative value. Cosby said the power is negative. Do you agree? Do you agree? If you were to change it to the exponential form, in logarithms, we are trying to find the power, right? So he said that this is the power, it is negative. Do you agree with that? Which means that 5 to the power of this one gives you. Does that make sense to you? Why?
You move over the power law, right? You move over, right? You just move back the power law, so you're finding x.
Oh, that's not what I'm looking for. Does this make sense to you? 5 to the power of something, you get something smaller.
Yes.
5 to the power of something, then you get an even smaller number. How does that happen? When there's a negative power, this becomes a fraction. This becomes a fraction. Okay, on the left hand side, this is what I see. This is actually the same as 5 to the power of 0.139, but we have a 1 over. Get it? Because negative power, so this will give me a fraction. Alright? Next. Practice now 20. A, B, C, D. Practice now 20. A, B, C, D. Yep. Part A. Log base 2 7.16. How do I show the working for change of base? Log 7.16 divided by log 2. Okay, use your own calculator, figure this out. Okay, whatever it is, I'm sure you can get it correct. Log base 4e equals to?
Log e over log 4.
I prefer to use something else. Ln, ln, e divided by ln 4. 4. Okay, what does this give me? Numerator? What is the numerator? 1 over ln 4. Yes, you are right to choose log e divided by log 4. You'll still get the same answer. Okay, but just note that since there's an e, then might as well use ln, because I'll get 1 over there. I'm taking ln on both sides. They must have the same base. If you are using ln over here, you must use ln. If you are using log base 10, you must use log base 10. If you are using log base c, you must use log base c. Part C, log base 8, 3 over 2. Okay, ln or log? Log, okay, log 3 over 2 divided by log 8. Log 1/3 root 5. That's the last part of the lesson. Log A, B. Okay. I get to change the base to anything I want, right? What if I try to be funny? I change the base to, on the left hand side, what's the base? A. What if on the right hand side I change the base to B, for example? Can you go and investigate what happens if I change the base instead of C? I change the base instead of C to become B. Try it. Try. When C equals to B, then log base A, B, log base B, B, divided by log base B, A. Okay, equals to 1 over log BA. What do you notice about this? What interesting things can you see about the last step?
It's like the negative. It's like the log. It's like negative 1 log.
What do you notice? When I have log base AB, then I change it to log base B, right? Do you see that it's like a switch over here? Then over here also switch, right? But you can't just switch like that. You need to put 1 over. So this is the next one that you need to know. The relationship over here in red. As long as you see a need to change this base to become B, just put a 1 over and then switch the positions. Okay? This is the proof, and the red one is the result. Now let us take a look at practice now 21. Part A. Find the values without using a calculator. So log base 5, 8 times log base 2, 10 times log base 10, 5.
Not all same bases.
Yes, okay, the bases are all different. We don't like a situation when all the bases are different. So you choose a base that you like to convert everything to. Base 10? Base 10 is always, is usually more convenient. Besides, it has already appeared here. Let's change that to base 10. So log 8 divided by log 5 times log 10 divided by log 2 times log 5 over 1. What's the point of writing it this way? I have fraction multiplied by fraction multiplied by fraction. Yes, then? Say again. Write them into a single fraction, yes? Yeah, you're right, but I want to cancel wherever I can. Yeah, okay, log 5 and log 5. Anything else that I can cancel? Log 8 and 2, how to cancel? Log 10, oh, log 10 is actually 1, right? Anything else? Log 8 and 2, what can I do with them? How to cancel? 8, you must be very sensitive to the number 8. Just like when you see 4, you must think of 2 squared. 2 power 3. 8 is actually 2 power 3. Let me rewrite this. This is 2 power 3. Then I see 2 power 3, what do I do? 3 log 2, okay. Then what do I do now? Yes, cancel. Log 2, log 2. What's the answer? 3. Understand? Let us try part B. Log base 7, 4. Log base 2, 9. Log base 49. Root 3. Okay. What base do you want to change it to? Sure, go ahead and try.